Okay, so we have solved a few equations, and we have some general rules. Number one, the variable must be alone. Number two, you're going to get rid of the coefficient and the constant by applying the opposite operation with the same number. So for example, if you have something like n 2n plus 4 equals 19, to neutralize the 4, you are going to subtract 4. Okay? So same number, opposite operation. And what you do to the left, you're going to do to the right. We've got some very general rules about this. Okay? So here's what I'm going to do, is I'm going to give you a few equations to work on. And I would like you to try to solve them using algebra tiles if you wish, and then I will offer a solution. So after I put up the equation, I would like you to pause the video, work it out for yourself, come to a solution, and then start the video again to see the solution that I come up with, so you can see whether ours match or not. And who knows, maybe I'll make a mistake. Okay, so here we go. So we're going to go with 3x plus 4, and we're going to have that equaling 19. So I would like you to pause for right now and work it out, and then restart to see the solution. Okay, I'm going to begin by building my model right here. Okay, so I've got my 3x and I'm adding 4, so there are my 4. 1, 2, 3, 4. Then on the other side, on the right side, I'm going to make my 19. 1, 2, 3, 4, 5, 6, and nope. I will just repeat that. That's going to give me 18. And one more will give me 19. There we go. So I've made my model. Now, I want x by itself. So I'm going to start by dealing with plus 4. And I'm going to do that by subtracting 4. Same number, opposite operation. And on the other side, I will subtract 4. There we go. When I simplify, so how's that going to look on my screen? Well, I'm going to take away 4 from this side, and I'm going to take away 4 from the left, because I need to do the same thing on the left and the right. So the addition of 4 has been countered by the subtraction of 4 that you just saw, and that leaves me with 3x on the left side. 19 minus 4 is 15. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I'm good. Now, I have 3x, and I need to neutralize the coefficient of 3 by using the same number with the opposite operation. So I'm using a 3, but I'm dividing. Okay? What I do to the left, I do to the right. Divide by 3. And what does that look like in my model? Well, it looks like this. I'm going to divide into 3 groups, and then I'm going to make some groups here. That's too many. And my groups are going to be equal, so I'm going to move things around, and there I have 3 equal groups. And if I take a look at, say, one of these groups, I have x equals 5. So 3x divided into 3 groups, I'm looking at 1x, and 15 divided by 3 is 5. So I have x equals 5. Now, if I go back to my original equation, I'm going to test it out. I've got 19 on the left side, so let's see what happens, or on the right side rather, and let's see what happens when I put 5 into the right side. Oops, that's plus. 3 times 5 is 15, and I've got plus 4, and that equals 19. So that's a good solution. So let's try another one. And again, I will write it, then I will let you work on it, and then we will see what happens. So we're going to go with x over 2, x divided by 2 minus 3 equals 7. So take a minute to work that one out and pause it. Pause the video. Okay, so x over 2 is kind of tough. Okay, so what I'm going to do is I'm going to say this is my x, and I'm going to rotate it this time for a purpose, and I'm going to split my workspace into two spaces. So you can see that half of x is on one side and half of x is on the other side. And for a minute, I'm just going to use this block here, pretend it's not x plus x squared. We're going to use this block to cover up half of x. So I'm only looking at half of x here. The half of x that I'm looking at is right there. So I've done half of x. Now I need to subtract 3. So I'm going to put 3 negatives, but I'm going to put them up on this side because the subtraction of 3 only corresponds to the half of x. Okay? And on the other side, we're going to have 7. 1, 2, 3, 4, 5, 6, 7. Okay, great. So, first step, deal with the constant, the subtraction of 3. Okay, so I'm going to counter the subtraction of 3 with an addition of 3. Here we go. 1, 2, 3. And what I do to the left, I do to the right. 1, 2, 3. And so that's going to look like this up here. So I'm adding 3 and adding 3. Now, as we know, subtracting 3 and adding 3 causes this to happen. I have the same number of negatives as I do positives, and so they cancel each other out. So now what I have, quite clearly, is I've got half of x equaling 10. All right? Half of x equaling 10. So I'll just write that out now. I've got half of x equaling 10. Now, if this half of x equals 10, if this half of x equals 10, then this half of x is also going to equal 10. So I'm just going to put 10 down here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And when I pull it all away and look at x, well, what does x equal? It equals 20. So what did I just do there numerically? I multiplied by 2, using the same number with the opposite operation. I multiplied by 2, and x divided by 2 times 2 is x. 10 times 2 is 20, and so I have a solution. Now let's just think this through really quickly. If I put 20 in the position of x on the left side, 20 divided by 2 is 10, minus 3 is 7, and that proves that our equation is true.